Hey everybody, welcome back. In this video, we're going to explore digital outputs using the classic example of blinking an LED. And this exploration is going to tie together a number of different building blocks that we've been looking at for the last little while. And if you need to, you should go back and check those videos to refresh your techniques and skills around some of the things we're about to see. On my breadboard, you can see that I've got an RGB LED that is connected to an Arduino. And in the Arduino, I have uploaded some code that is selectively turning on digital pins. And it is in sequence turning on the blue LED and then the red LED. And in this video, we're going to explore how that works and the conceptual relationships and the idea of a digital output and bring all of that together with the code. Before we look at the circuit built-in code, let's just talk a little bit about what is a digital output. You're going to see this matrix a lot throughout the course. This is sort of a bird's eye view of the main relationships that we're going to explore when relating or creating relationships between our Arduinos and circuits. And these four different contexts can be broken out into either digital or analog circuits, and they can be broken categorically into inputs or outputs. This video is focusing on digital outputs, and we're using a blinking LED as an example of a digital output. And you should know that you can blink much more than just LEDs. Sometimes the LED is the thing you need to be turning on and off, but sometimes that's just a placeholder for other elements that you might want to control or use in a project. It may represent a fan or a motor or some other kind of component that you're going to integrate later, and you just want to test with an LED to get started. Let's look at some of these terms, input and output. Whenever we discuss an input and output, we're always discussing these from the perspective of our Arduino. When input is an electrical signal that moves into the Arduino, and an output is an electrical signal that moves out of the Arduino. And this is going to be a digital output, so we're going to be focused on outputs in this video. Digital refers to signals, circuits, or logical systems that have only two states, things that can be on or off. And this relates to the logical space of true and false, and it relates to the electrical space of positive power supply and ground. And we're going to explore what that means. So a digital output is an on-off signal that moves out of the Arduino. There's a simple line of code that you're going to use whenever you're creating a digital output, and that line of code is digital write to a pin and what state do you need that pin to be in. So a pin is one of the digital connection points on the Arduino. And the state can, because it's digital, only be high or low, 0 or 1. And again, 0 and low, those correspond to the ground side of a battery pack or the ground side of your Arduino power supply, and 1 and high correspond to the 5-volt side of power in the Arduino. Remember, Arduino is a 5-volt device, not a 9-volt device. There's a reference card in your kit that has all of this information, the context, the command, the circuit, and the code all in one place. So if you get stuck or as you're going along in this video, you should have that card out and be looking at it as we go. Now let's recall the first circuit that we built on a breadboard. It's a simple LED and resistor in series connected to a 9-volt battery. We can remind ourselves what that looks like. Battery pack, followed from the positive side of the battery supply into an LED, to a resistor down here. This one's 470 ohms, back to ground. We can take that representation of the circuit and we can turn it on its side. And if we do that, we see that it's the exact same circuit, just drawn in a slightly different way. And we can take that representation one more transformation, and instead of showing the battery pack, we can put the red bar at the top of this image to indicate the plus side of power in the circuit. And we can draw a black bar at the bottom of the screen to indicate ground. The representation changes, but the circuit's the same. We travel from the plus side of the battery through the LED, through the resistor, and back to ground. And now in terms of digital outputs, this is the most important transformation. We can remove that connection, that permanent connection to plus voltage, and connect instead to a digital pin on our Arduino. We represent that digital pin with that black flag in the middle of the screen, and we put the number of the pin in that flag. So this circuit says, go from pin 5 of the Arduino to the LED to the resistor, and then we'll keep a permanent connection to ground. Let's have a look at what that might look like, and then we'll build that out. The representation on the very left is the schematic of the circuit we just looked at. We then have a drawing of that circuit, and let's look at what we'd have to modify in our breadboard to pull this off. We can see in the representation here that we've got an LED and a resistor. We've still got that, but nowhere in this representation is a battery pack. Let's start by getting rid of the battery, and I'm going to disconnect the clip. Remember, it's dangerous with these guys to have the clip on the battery because these two live ends can touch. So if this is not connected on this end, this has to come off the battery pack. Let's get that right out of here because we don't want the 9-volt battery supply in this image. We can bring our Arduino into play to match what we're looking for here. And we need to remove this connection here. And what we want to do now is build a connection that goes from, according to this schematic, pin 5 on the Arduino over to our LED. Let's look at what that's going to do. We find digital pin 5 and we insert the wire into that tie point. And we connect the other end of that wire to the anode side of our LED, the long leg near the round side of the cap. If we follow that circuit along through its connection, so we start at pin 5, we go through that blue wire, we have a connection to our LED, our resistor, and we follow along the ground leg at the bottom, or the ground rail, and we see we need to make one more connection over here. And just to show you the different ways we can make connections, I'm going to do this connection with a DuPont wire with male headers on each end. One end of that DuPont wire is going to go into here, and I'm going to tie a lovely loop in it to kind of contain it. And the other end of that DuPont wire goes into a ground header on the Arduino. So my circuit goes from an Arduino pin through an LED, through a resistor, back here to ground. And in fact, just for visual fun, I'm going to get my containment loop off the top of my circuit here. There we go. This connection between the Arduino and the LED circuit is really the fundamental shift that we're looking at. Instead of a permanent connection to positive power supply, we're now connected to an Arduino pin which can provide a signal. And that signal, because it's digital, can either be a high or a low, a positive connection or a negative connection. So I've got the circuit that we've just built in the Arduino software. I've got the single LED example open. Let's start by uploading the code and then discussing how it works. So we built with the power off. We're going to connect USB. As soon as we connect our USB cable, the on light comes on the Arduino, and in the software we're ready to upload. You should double check that you've got Arduino Uno selected for a board, and you've got the correct port, the one that indicates Arduino Uno, so that you are pointing in the right directions for your upload, and then find the controls in the Arduino software and click the upload button. As soon as the code uploads, you'll see that the red LED on the breadboard starts to blink. Let's talk about what's happening in the code to make that possible. We have a declaration on the second line. It's an integer, it's a variable declaration, and an integer is a number without a decimal point. And the name of this variable is LED pin. And you can use any name I suggest you use names that identify the kinds of circuits you're controlling or whatever it is you're building. Controlling an LED here, so LED pin makes sense. And the really important part here is the setting of the variable number 5. And it's number 5 because we connected our circuit to pin number 5 in the Arduino. Down in the setup, and remember setup's a function that happens only once, we have to set the pin mode, and this is the direction of current flow, and we're setting it to output, which means current's going to flow from the Arduino out to the board. And then the last function here is loop, and void loop is a function that goes over and over and over again once you power up your Arduino, and it has 4 active lines of code. The first one is that digital write command that we said is an important part of digital outputs, and we have to tell the digital write command which Arduino pin is being controlled and what state we want to set it to. We are controlling the LED pin, the pin where we put our circuit, and the state can only be high or low, and we're going to put in a high. When we say high in our code, 5 volts flows from that the pin we've selected out to the circuit it's connected to. We then have a delay, and the unit of time in a delay is milliseconds, and there are 1,000 milliseconds in 1 second, so a delay of 1,000 pauses for one full second. We then have another digital write, again to which pin, which circuit are we controlling, pin number 5, and now we're going to set it low. Pin number 5 is now going to be connected to ground, and when that happens, the LED goes off. And finally, one more delay of another second. Let's go back to the slides and look at a representation of what's going on inside this circuit. When the command digital write 5 low is used in our code, the Arduino pin that we've selected gets connected to ground. There's no voltage difference in the circuit. The potential of both ends of the circuit is at ground, and no current is flowing, so the LED is off. When we issue the command digital write 5 high, we connect pin number 5 of the Arduino to 5 volts. We have a voltage difference across the circuit now, and current can flow from pin 5 through the LED, through the resistor, and to ground. And as these commands are alternated, the amount of delay in each case controls how long we stay in each state. Let's now look at one final extension of this circuit. Let's extend this idea to our red, green, blue, our RGB LED, and see what we can do with that. In this schematic, we have the RGB LED symbol encased or enclosed in that pale blue outline. Normally you wouldn't show a physical attribute of a component in a schematic, but I just wanted to be clear where it is. And note the RGB, as we know, has 4 pins, a pin for the blue LED, the green LED, and the red LED, and those project to the left with simple LED symbols attached to them, and then a pin, a single common pin that will connect us to ground. Let's start this build, and then we'll come back to the schematic and finish off what we need to do. And let's go back and look here. We need those 2 1K resistors. The blue connection to pin 5. We need a connection for the red channel to pin 10. And we're ready to go look at code. In this image, we've got the circuit we just built. We've got this time blink red blue code, open and waiting. Our old code is still in the Arduino. The circuit on pin 5 is already receiving current, but that's not what we want to do. Let's upload our new code here. Again, it's blink red blue. And let's see what happens when we upload this code. So with this new code in, our LED blinks blue and then red in an alternating fashion, and let's look what's happening in the code to make that happen. 2 pin declarations this time, one for a blue pin and the other for the red pin. The blue pin is on circuit or digital pin 5 on the Arduino. The red pin is on digital pin 10. 2 pin modes to set because we have 2 circuits to control. The red LED and the blue LED, both of them set to output because we're sending a current from the Arduino out to our breadboard. And then in our loop, exactly the same code as we used in our last example. The blue LED gets, using digital write, the blue LED is set to a high voltage. 5 volts flows through the blue wire, wait for a second, connect the blue wire to ground to turn the LED off, wait for another second, turn the red LED on by setting pin 10 to 5, wait for a second, and turn the red LED off with digital write LED low in line 23, connecting the red wire to ground, and delay for 1 more second, and then repeat indefinitely. Let's look at what's going on in this circuit. When we have the combination of a digital write 5 high, so that's pin 5 is connected high, that turns the blue LED on. 5 volts flows from Arduino pin 5 through the 1K resistor, through the blue LED, through the 470 ohm insurance resistor and down to ground. At the same time, when we have digital write 10 low, the circuit connected on pin 10 gets connected to ground, so that's through the red LED, and you can see the red LED has both ends of its circuit connected to ground, and the LED is not illuminated. We change states though, using words. Digital write 5 becomes a low. The blue LED gets turned off because 5 is now connected to ground. There's no voltage difference in that circuit. Digital write 10 high sets the pin 10 to 5 volts, and current now flows from pin 10 through the 1K resistor, the red LED, and that insurance resistor back to ground. And again, we can switch these circuit states back and forth and control the different circuits connected, in this case within the RGB LED, to set different colors glowing at different times.